More examples, we are going to employ more techniques in this example and then this, but please don't forget to subscribe to the channel. Okay, now this one says the roots of the equation with this are alpha squared and beta squared. Now, most of the questions were alpha and beta, but this time they are squares, alpha squared and beta squared. Find the equation whose roots are alpha and beta. Now, this one is a beta. So what we do, we always, if the roots of this equation are this, what we start with, we always get the sum and we get the product of the roots to that equation. So now, let us find the equation now whose roots are this middle. We need the sum and the product of these new roots now. But first, they gave us these roots to this equation. So now, if I compare, here my A is 1, my B is negative 21. The coefficient of x and there, then C is a 4. Now, the sum of these two roots, now I come and get their sum. So the sum is alpha squared plus beta squared. Of these particular roots, when you come there, you say that always the sum is negative b, so negative into, from here our b is negative 21 over a. Our a here is 1. And so this one is giving us 21. So mean that alpha squared plus beta squared is giving us a 21. Now I come to the product. So my product here, the products of these roots are, is x alpha squared plus beta squared. Times beta squared. And so that always the product is c over a. Now, the product here is that our alpha, these are in the same power, so you can put them under the same power like that. Our c, from here, our c was 4 over 1, and you see that this one is giving us a 4. So alpha, beta, the whole square is giving us this. Now, they want us to get the whose roots are alpha and beta. Now come and say, for alpha, comma, beta, now here we need also the sum of these ones. So this one I'm going to call it the new sum. So our new sum is alpha plus beta of the roots of the equation we want to get. Now I need alpha plus beta. Now how are we going to get alpha and beta? Now for me, I know that we can always express this in terms of the sum and the product. We know that from alpha squared plus beta squared equal to 2. We saw this in our first lesson. These are all symmetric expressions. We said that the whole of this is equal to this. Why? I'm trying to express so that I can get my sum, the one they need to get. But I have this already from here. It's equal to 2 and 21. So now I need alpha beta. From here I can get alpha beta if I get a square. So we said alpha beta, the whole square here is the same as 2 squared. These powers are the same. It means that now our bases are also the same. 4 is the same as 2 squared. Same power, means that also the bases are equal. So I have this as 21. So this is 21 equal to 2 alpha plus beta the whole square, then minus 2 into now alpha beta. From here I'm saying it's 2. So this one is going to give me a 4, which I take this side. I have now 21 plus 4 equal to 2 alpha plus beta the whole square. And from here, it's that now my 25 is the same as 5 is squared is equal to 2 alpha plus beta squared. Same powers means that the base is the same. So our alpha plus beta. So I have now the sum. Now the product, the new product, so it's that our new product is always alpha beta from here, which is C, our alpha beta already, and 2 from there. Now these are the equation they want me to find would be, it says the generates x minus the sum of roots into x, then plus the product of roots equal to 0. So now my x squared minus my sum. So the sum of these roots is 5 into x, then plus the product, which is 2, equaling 0. That would be the equation there. As simple as that. But to come out to this, if alpha and beta are roots of the equation, this find the equation whose roots are alpha, root alpha, and root beta. So now, here we are going to apply another technique. We saw that from here, this one was the square of this. And so now this one is also square. When you square this, you get this. When you square this, you get this. This one, when you square this, you get this. When you square this, you get this. So it's just the same idea, just like here they use now roots. So now, in my solution, my original equation is 12x plus 4 equaling 0. Now from here, sub 9a, if I compare this one, my b negative 12 and my c is 4. Now, the roots to this equation, the roots of this equation are alpha plus beta. So their sum is going to be alpha plus beta. And you say, whenever you get it, it's always going to be given by negative b over a, which will be negative 12 over a, which is 1, and so this one is going to give us 12. So if I now alpha plus beta is 12, when you just substitute from there. Now I come to their product. So their product. Okay, let me write here the product. So the product is going to be alpha times beta. We said this is given by c over a. So our alpha beta. Here our c, from here our c is 4 over a, which is 1, and so our alpha beta is equaling to 4. Now, find the equation whose roots are root alpha and beta, so root beta. So these are now the new roots. We need to get, in order to get the quadratic equation, we need to get the sum of the roots and the product of the roots. So now we get the new sum. For the roots, this one. So it's going to be root alpha plus root beta. Now the question is, how do I get that? Now, because you know that after squaring these ones, you shall be getting there. Now I said from, look at this. From, when I square root alpha plus root beta and I square it, how can we expand this? We say you square this, you get alpha plus this and this, then by 2, so 2 root alpha beta, then plus you square this, you get beta. So you see this will be, when I combine this, plus 2 root alpha beta. Now, my alpha beta, you see in this equation, my alpha beta is 12, then plus 2 root our alpha beta. Our alpha beta is 4. And so the whole of this now, root alpha plus root beta, the whole square is going to give us a 16, which will be 4 power 2. Same powers means that now root alpha plus root beta is going to give me a 4. As simple as that. Now I come for a new product. My new product is going to be root alpha times root beta. For these roots, the ones I want to get. So start this one, you multiply numbers and the roots. It's the same as getting those numbers, multiplying them separately. I mean together. But our alpha beta, from here our alpha beta is 4. And so this is going to give us a 2, as simple as that. Okay, so now from there what happens? I come and I say now my x squared minus the sum root alpha plus root beta into x, then plus their product root beta, okay, root alpha times root beta, the whole equaling 0. This is x squared minus the whole of this is giving us a 4 into x, then plus alpha, this one is giving us 2 equaling 0. So our equation is x squared minus 4x plus 2 equaling 0. Someone is asking, can ask, because when we get the square root, we get plus or minus 2. So here, because here I took only the one for positive, I remember I compared the bases. I never took the square root. That's why I'm here. I'm also taking the positive part. As simple as that. So that's it, members. I wish you well. Okay.